Where does electricity come from? Electrical energy is a convenient and important kind of energy. For over 100 years, people have put it to work in almost every area of human life. Americans use about 3.9 million kilowatt hours of electricity every year. 1 kilowatt hour is equal to the energy needed to light a 100-watt light bulb for 10 years. The term electricity generation refers to any one of several types of energy that is transformed into electricity. The transformation is usually done at a centralized power plant, which then distributes the electricity to the area around the plant. The first power plants burned coal to generate electricity. As well as coal, today's power plants run on other fossil fuels, the force of water, and nuclear energy. The newest ways of generating electricity, often called alternative energy, include solar power, tidal harnesses, wind generators, biomass, and geothermal resources. In fossil fuels, biomass, geothermal, or nuclear power plants, heat is released that boils water. High-pressure steam from the water turns the blades of a turbine. A turbine is like a large fan that uses mechanical energy to turn the blades. Then a generator transforms the rotating energy of the turbine into electricity. Electrical power comes mainly from regional power plants. Those power plants are themselves fueled by various energy sources. In the United States, the major sources are coal, nuclear power, and natural gas. The chart on the next page shows the types of electricity generation we use in the United States and in what amounts. The map on the next page shows what parts of the country use what kind of fuel. Non-renewable resources, fossil fuels, coal, petroleum, and natural gas. Fossil fuels such as coal, petroleum, crude oil, and natural gas come from plant materials and small animals that have been buried in the earth for millions of years. They are non-renewable energy sources because it takes millions of years and special conditions for these fuels to form. Fossil fuels are convenient for us because the United States already has the infrastructure, such as railroads near coal mines, pipelines, power plants, and relay stations, to get and transport these fuels and transform their potential energy into electrical energy. Another advantage of the fossil fuels is that the amount of energy released per kilogram of fuel burned is much greater than what burning renewable fuels such as biomass produces. The efficiency for burning varies depending on the fuel, but fossil fuel efficiency is about 38 to 47%. A big problem with burning any fuel is that it produces carbon dioxide, which contributes to global warming. Coal is the leading fuel source for electricity generation in the United States. When coal burns, however, the gases that are produced are a major air pollutant. A growing body of evidence suggests that carbon dioxide released from burning fossil fuels is the major cause of global warming. Petroleum, which is the raw material for gasoline, diesel, heating oil, and other fuel oils, and natural gas produce less pollution than coal. Natural gas produces the least pollution of the fossil fuels, but releases the least amount of energy per kilogram. There have been some technological advances that can reduce the amount of pollutants released during burning, particularly at coal plants. Nuclear energy. When atoms of radioactive elements such as uranium and plutonium are split apart, a huge amount of energy is released. Nuclear energy plants do not produce the air pollution of fossil fuel burning plants, nor do they produce carbon dioxide. The efficiency of a nuclear power plant, however, is about 35%. Of greater concern, nuclear power plants generate radioactive waste that can cause severe health and environmental problems. As a result, waste from nuclear power plants requires special handling, containers, transportation, and storage facilities so that the waste is safely contained for millions of years. The danger to nearby communities in the case of an accident is far greater than for other kinds of power plants. Nuclear fuel is usually categorized as a non-renewable resource because the uranium mined from the Earth cannot be replenished. However, a small amount of uranium can generate huge amounts of electricity. Compared to the chemical energy such as a fossil fuel, nuclear energy releases the largest amount of energy with the smallest amount of mass. Renewable resources, biomass energy. Some power plants can burn biomass such as wood, paper, organic material, or even garbage. The energy released by the burning is transformed into electricity in a similar way as energy is transformed from fossil fuels. Unlike fossil fuels, biofuels are a renewable resource because we will always produce waste products and we can continually grow plants for the biomass. Burning biomass can decrease the amount of waste that ends up in landfills, but it raises some environmental concerns because burning biofuels gives off pollution, although less than that from burning fossil fuels. Burning just about anything, even organic material, releases carbon dioxide that contributes to global warming. Even burning wood releases toxins such as carbon monoxide into the air. Sometimes collecting and transporting enough biomass to keep a power plant running is inefficient because the amount of energy per pound of biomass burned is not high. The efficiency varies from 22 to 40% depending on the material burned. Geothermal energy. Geothermal energy is the product of heat transferring from the interior of the Earth, the prefix geo means earth, to the surface. Thermal energy in some places inside the Earth is so intense that the water seeping through the area boils. Energy companies pipe the naturally occurring hot water, steam, and other hot gases to the surface where it will run turbines or heat buildings directly. Once the water is cooled, it is injected back into the Earth where it then reheats. Some of the steam and other gases are released to the air. Unfortunately, some of the gases are foul-smelling. Generally, however, geothermal power does not pollute the air or release carbon dioxide. Geothermal power plants do not take up much room, and little or no other kind of energy is needed to run them. However, the efficiency of a geothermal plant is only about 15%. One limitation of geothermal energy is that only certain places on Earth have water under the Earth's surface hot enough to be used for geothermal plants. Many of these plants are near active or recently active volcanoes, and many people do not want to live nearby. The amount of heat in the Earth is enough to classify this type of energy as renewable, although some geothermal regions eventually cool down. Hydroelectric energy. In a hydroelectric plant, moving water turns the blades of turbines. The prefix hydro means water. It does this by transforming the gravitational potential energy of water at the top of the waterfall into kinetic energy and then into electricity. While naturally flowing rivers and streams can be used to produce small amounts of electricity, large hydroelectric plants usually require the construction of a large dam. Hoover Dam, a large dam on the Colorado River, created a waterfall of 122 meters, 400 feet, which is more than twice as high as Niagara Falls. Hydroelectric power is a renewable resource because the water cycle continually supplies water to streams and rivers. Building hydroelectric dams also creates lakes and reservoirs that increase the local water supply. This kind of power does not produce any pollution or waste outside of making the dam. Although building a dam is very expensive, once the dam is built, the cost of power is very low. Its efficiency is the highest of all types of electricity generating plants and can be nearly 95%. Dams do have a negative effect on the environment, such as loss of fish and other aquatic animals and plants in the area. Building a large dam floods the area upstream in some cases, drowning out forests and forcing whole towns to move away. Downstream, the amount and quality of water may also change because the dam will have changed the flow of water. Solar energy. Energy from the sun can be converted directly into electricity by solar cells. No turbine or generator is necessary. This makes solar energy a convenient way to get electricity. The sun's energy can also be used to heat water and other liquids to spin turbines, although this is less common than solar cells. Some solar energy is collected on a small scale of individual houses, which can easily power an individual home. Making the equipment for solar power produces some pollution, but using solar power does not. The efficiency of a solar cell to convert energy is about 15%. There are large-scale solar facilities designed to serve the needs of a whole community. It takes a large number of solar collectors and therefore large areas of land to collect enough solar energy to power a community. Although solar energy is a renewable resource, communities relying on it need storage facilities or other sources of electricity for nights and cloudy days. Some parts of the country would have trouble generating enough electricity for their needs because of their climates. Tidal harness. Tidal harness captures the kinetic energy of ocean water between high and low tides. This kinetic energy turns the blades of a turbine connected to a nearby generator. This type of energy only works in areas where there is at least 3 meters, 10 feet difference between high and low tides. Because tides are predictable, the energy is reliable. The efficiency is nearly 90%. Once the equipment is built, there is almost no chemical pollution. However, the equipment is so large that it increases the turbidity of the water nearby, and this affects birds and other wildlife. Although not used in the United States, there is hope that it may become a major source of energy here in the future. Additionally, huge floats that can use the waves to turn blades of a turbine can harness the energy in ocean waves. Since waves are free and the equipment does not cost very much, there is almost no cost for the energy. However, waves are unpredictable and it takes large waves to produce a significant amount of electricity. Not all areas around the world have consistently big waves. The equipment is noisy and it is easily damaged by the constant pounding of the waves. Wind energy. Wind, which is simply moving air, can turn the blades of turbines. Today, large assemblies of windmills known as wind farms have been set up in areas of the country where the wind blows for long periods of time. Because each wind turbine produces a relatively small amount of electricity, vast areas of land are needed to hold all the windmills it takes to produce significant amounts of electrical energy. There are also small wind turbines designed for household electricity production for people who live in windy areas. As with solar power, wind energy can be a good power source for people who want to power their own homes. Windmills generate no pollution beyond that produced while making them. They do create some noise and they can disrupt the environment. In some places, certain species of birds and bats have been caught in the blades and killed. Although wind energy is a renewable resource, communities relying on it need large storage facilities or other sources of electricity for times when the wind is not blowing.